Hi everyone, welcome to the DevOps Connect from BMC. And I'm just going to hand it over to Stacey to give us some housekeeping on the platform.
Hello, and welcome to today's webinar, Say Yes to Mainframe DevOps Part 2. Before we get started, I'd like to mention that today's webinar is being recorded and you are currently in a listen-only mode. The recording will be made available within the next few days following today's live session. Now, I'd like to acquaint you with some of the ways that you can participate during today's presentation. The room you are in today allows you to join via computer audio or telephone audio by clicking the arrow in the top right corner of the control panel. We encourage you to submit your questions at any time throughout the session using the Q&A panel located on the bottom portion of your screen. Simply type your question into the lower window and be sure to hit send to have your question placed in the queue. We'll address as many questions as time allows. During today's presentation, we will ask for feedback from you by voting on a polling question. This will appear in a pop-up window directly in your slide area. Please vote by clicking the radio button that corresponds to your answer and then hit submit to register your vote. Finally, if you experience any technical difficulties during today's event, first try refreshing your browser to reset your connection. If that does not work, enter it into the Q&A pane stating your technical issue, and I'll be more than happy to help you resolve any difficulties you may be experiencing. Now, without further delay, let's begin today's event, Say Yes to Mainframe DevOps Part 2. I would like to introduce you to your moderator for today, Stuart Ashby with BMC. Stuart, you have the floor.
Thank you, Stacey. Welcome everyone. And I'm joined by Reg Wilkinson, and Reg has been working at Lloyds Banking Group for some time on his Mainframe DevOps journey. We're going to spoil all of the interaction, but I did want to say that this isn't their day one proposition. They've been on this journey for a while with many options and twists and turns on their DevOps journey, but I think it's a great opportunity to see what elite DevOps organizations can achieve on the mainframe. So, Reg, let's talk about what we're going to discuss today. Just three simple areas. What about the mainframe's just another server in the data center? And then modern engineering on the mainframe. And then what comes next? How does that sound?
Yep, let's go for it.
Good, because that's what we rehearsed. So, most important topic, you. Give us a bit of a rundown.
So I'm a software engineer by trade. I have been working on software in large organizations since the last decade of the last century. I didn't originally intend to work on the mainframe. I rolled up at Bank of Scotland as a grad work placement, wanted to do Java. I could also answer the mainframe questions, and I found myself working on the mainframe. Fast forward until last April, the last thing I did as a software developer on one of the application teams was to write some Java code for the mainframe. I've now changed roles and I've kind of become poacher turned gamekeeper or gamekeeper turned poacher, depending on which way you look at it. And have moved into DevOps on the mainframe full-time. My old team, we were one of the early adopters for lots of things that Lloyds tried, and we were one of the original pilot areas.
So it's interesting because I think what we're going to talk about today is a lot of bringing the stuff from the distributed world, making it mainframe relevant, and that's where that first bullet point of our agenda was the mainframe's just another platform. Have you got anything to add before I bring the graphics on, or do we just want to get the picture up?
We've got an image problem. If we bring the picture up. So we do have an image problem. I've used a slide fairly similar to this at one of the bank's DevOps advocate meetings, where we had about 200 engineers from across the organization in a room in London. And we had those guys were doing lots of busy presentations about Node.js and stuff they were doing in React and all kinds of cool stuff. And then I got up to talk about what we're doing in the mainframe, and I pulled up a picture fairly similar to this, and said to the guys, put your hands up if you think, when you think of a mainframe, what do you imagine? And I showed them the picture down there of the US Department of Agriculture collecting its first IBM mainframe, and pretty much the entire room put its hand up. That's what they imagine a mainframe to look like. So I don't expect to get smoke in my hair and risk smuts and all that kind of stuff when I jump on a train heading to London. I want somebody to give me breakfast, and I don't want flying helmet and goggles when I go on holiday. I think the problem with the mainframe is it's never really been visible. So guys who have worked with PCs over a number of years have seen things evolve from a box that you could break your foot if you dropped it, and had to carry it around the office when you changed desks, through to something quite slick and that you can pop in your pocket. The rest of the engineering community within my organization tended to think that the mainframe had stuck in a rut when the original one was installed in the mid-60s, and it just is the same kit doing the same thing, and it's a bit of a dinosaur, and obviously it's not. So we do have an image problem. We have an internal sales pitch to do within our organizations to say that the mainframe is not only still relevant for the, I'm going to use legacy in the good term, because it is the container for so many business critical applications, so much business critical data. It's the golden source for many large organizations, so it is still very relevant. We should embrace it rather than try and find a way of getting rid of it.
Totally with you on that. And we do hear about mainframe modernization, but we know, you and I know, and I'm sure some of the audience know, that it's a pretty modern compute platform, but what it does potentially need is some modern engineering techniques or approaches on the mainframe. So we're going to bring up some pretty icons of things that may not necessarily always be associated with the mainframe. Do you want to give us a bit of a chat on these tools?
So in my career, I have worked on 2 brand new mainframe applications, and there are big gaps. So the last one was 7 years ago. Realistically, I don't think most organizations are going to create new COBOL, CICS, DB2, traditionally structured applications. A lot of this kind of dovetails into the doomsayers who say aging workforce, and the mainframe is going to be dead because nobody will know how to work on it because they'll all be dead. I think we should separate out the hardware platform from what the engineers are capable of doing. So I think we're going to have new blood coming into organizations. We had 10 apprentices started in my old team just before I left, and they're all multi-skilled engineers. So we taught them mainframe skills, but we also taught them modern engineering skills as well. So they learned GitHub. They arrived knowing things like Golang and Python. So why, as a mainframe, why don't we embrace that? The new blood will bring in new skills and new technologies, and we should be sort of championing that. We should be sort of welcoming them into our organization, not kind of beating them into submission to say, do something like we did in the 1970s.
Exactly. Who wants to be inflicted, have technology inflicted upon them? And you've got a mix of both closed source and open source stuff there. And the Accelerate State of DevOps Report 2021, which is on another screen, that's why I'm looking away from the camera, talks about that elite organizations are using open source and closed source. So what are the outcomes then if you bring all these things together?
Okay, it's a balancing act. So ultimately, we want to improve flow. Okay, it's all about speed to market. It's no longer big beats small, it is fast beats slow. And large organizations have a poor reputation for delivering quickly. My boss has an anecdote, which is, we'll call it phone the mainframe guy, where you've got a mobile banking app and you're deploying your mobile banking app using state-of-the-art DevOps pipelines until it gets to the point where the mobile banking app has got to talk to something on the mainframe that's new, and the pipeline stops, and somebody goes off and they pick up the phone and they phone a mainframe engineer, and can you do your thing now? And they sort of like bop along for a while, and eventually the mainframe guy phones back and says it's there, and the state-of-the-art DevOps pipeline continues. Why isn't the mainframe part of the state-of-the-art DevOps pipeline? So Urban Code Deploy in the middle, for example, is a tool that will quite happily coordinate deployments across multiple platforms. The mainframe can be one of those platforms. You can have that, the mainframe is just another server. It's a big box. It's the applications that are running on the big box are there because you need the quality of service that the big box gives you, right? But bits of your application could be running in public cloud. You could have lots of channels of engagement calling a DB2 database. Okay, the DB2 database is your main customer data store. You want to protect that. You want to make it highly available. You want it on a resilient platform. Okay, but if you lose the ability to support Android phones for 5 minutes, okay, that wouldn't be the end of the world. If your customer database got wiped out from your entire organization for 5 minutes, that could get your customers taken to Twitter, okay, or so yeah, so it's all about improving flow. That kind of leads into risk. So risk, again, we were chatting about the reason we've got the big boxes are because we need the quality of service, the aging workforce, the risk of transitioning. You need to again embrace what the new engineers are bringing into your organization and play to their strengths. From a cost perspective, the mainframe is an equal partner. If you had a spectrum of places you could deploy your application to based on cost, business risk, availability, the resilience required from the platform, you want to be able to build your application once and you want to be able to deploy it anywhere. And that would involve public cloud, hybrid cloud, private cloud, mainframe. It's just another platform, okay? And you would build your application on your desktop, on your Mac, whatever, test it in a container, okay, and then pop it on a pipeline which would deploy it somewhere based on your appetite for risk and the quality of service you want for your application, okay? And the whole thing can be automated and can be completely transparent, and the actual platform that's executing the thing that you want to run is hidden from the developer. Any complications from that platform are hidden from the developer. It's just as easy to take your container and deploy it to something running on GCP or Azure or AWS, to a box, an x86 box running in your data center, to the mainframe running in your data center.
Yeah, as you're saying about the orchestration, as long as the engineer is able to commit the code to version control and it builds then and passes all of the appropriate checks, then deployment can be automated to bring that final bullet there of the autonomy. Yeah. Yes,
absolutely. And the thing is, you want the same look and feel. Yeah, you want to, what's the current phrase is lower the cognitive load. You want to make the engineer concentrate on the things the engineers have to concentrate on, and all the noise is hidden and is somebody else's problem and is provided by the pipeline.
Yeah, and that's improving your flow and reducing your risk because everything's shifting left and you're getting those checks done, better code, faster, as John Smart would say, something like sooner, safer and happier. Right, so the audience have had a lot of listening. So now we're going to have a poll. Stacey, could you? Right, so poll is open. And just want to talk about parallel development because Reggie's going to touch on a relatively modern approach to code development. So parallel development, 1, do you do it all the time? 2, somewhat, projects can choose. 3, not really, all our development is discrete. And 4, we actively avoid it, which is 4 choices there, and we're polling away. I'm going to give it a few more seconds. So at the moment, 50% of the voters are saying somewhat projects can choose if they want to use it. And then a third of the audience are saying, yes, we do it all the time. 13% not really, and 4% no, we actively avoid it. So thank you for those answers. We'll come back to that in a little while, but we have another poll, and that is around Git. Do you see Git as your next iteration for mainframe source code version control? And choose one of the options. Yes, we're working towards that now. Maybe we're considering the options. Not really. We're happy with our current situation. We are using it for infrastructure source code. And yep, we plan to bring GitOps to the mainframe. So quite a healthy proportion are currently at the maybe we're considering the options. Just under a quarter are saying not really, we're happy with our current situation. And quite interestingly, 17% of the attendees, and maybe there's a lot of your work colleagues on the call, I don't know, Reg, but 17% saying yes, we're working towards that now. And so we've just covered parallel development. So a traditional mainframe approach, certainly when I used to set up SCM systems, there was always scope for parallel development. And then the second one was around using Git. And those are really going to tie into the Lloyds Banking Group, what's next, or what next in those modern practices. So what's engineering for the future look like, Reg?
It looks like a few bricks that I drew. You want to
Here we go.
So this is a bit of a story, and each brick kind of leads on to the next. So when we started, one of the first things we did was start to work on improving the developer's experience. So the red brick, the modern IDE. So we started to move away from just doing things in the green screen and giving the developer access to, in this case, it was Topaz, so which integrated with the tools that we're used to using on the green screen. So they had, but they got impact analysis as well as having debug and data manipulation all within the one IDE. First baby steps towards improving flow. Once we made the developers more productive, the next bottleneck they hit was, okay, so test environments, right? We can write code quickly, but if we can't test it somewhere, we're not going fast at all. So we started to look at using virtual mainframes, so IBM's AD/CD product, so the ZD&T, or whatever set of letters IBM are choosing to call it at the moment, which effectively is a 10-user mainframe. The CPU is a simulation, all the software is real, and the brakes are off, and this is your developer gets a mainframe in a container that they can play with, and that they have complete control, and that's a sandbox for them, and they can be independent from the rest of the team for as long as possible. So once we've got the developer with his modern IDE and he's now got a sandpit, we start to look at, okay, how do we get our application into that empty box? So we started to look at how we could describe our infrastructure as code. So that wasn't necessarily building lots and lots of Ansible scripts. To be honest, to start off with, that was just creating JCL. That was just jobs that would create the data sets. That was just jobs that would create the database. That was just jobs that would populate some test data. But good practice says you should start to version those. So the versioning tool that we had access to was GitHub Enterprise and Git. So this was the first toe in the water for mainframe developers to start to do parallel development on things, and they started to version the scripts that they were then using to populate our testing environments with their application. And that got the guys into the idea of branches and trunk-based development and all that kind of good stuff, and how to actually manage source code in a modern source code management tool. Next steps, okay, what can we do to start applying some of this to the real machine? So we're now doing this to our test environments. What can we do to a real machine that won't break how we're doing things today? We looked at our infrastructure, so DB2 databases and KICS. So taking the DDL out of DB2 as a master and having a master version of DDL that we could keep inside GitHub, and then we use the same deployment tools that the DBAs would use under the control of a pipeline to deploy that DDL anywhere. Now that, first of all, the reason we wanted to do it was so we could do parallel development on our database, which can always be problematic if you're doing things manually. The side effect that we got from that was that we found errors in our test environments. So because we had a master of our database stored in Git, and we were deploying that on our route to live, rather than just asking a DBA to add a column here or an index there, we tidied up our test environments on the route to live, which meant that we could actually go faster as a side effect, because we didn't spend time shaking down a test environment because it was ready and working for day one, and that has cleaned up our route to live for the applications that have embraced this technology. We've added that capability now to KICS, so definitions which are held in your KICS CSD, we are now versioning in GitHub as well, and again, using automated tooling, we're able to stamp out KICS environments on the route to live, which are all in alignment with each other. So we don't have surprises when we come in to test the application.
Yeah, and that makes such a difference. We've seen other customers of BMC using comparing DDL to catalog and then being able to ensure that everything is right rather than relying on someone not having made an online change to a database structure, that you can repeat these deployments. And then if you have change boards, then the tricky question around have you ever deployed this before used to be no. Now you can say, however many times the organization has needed to deploy it, it's just the same. Production is going to be just the same as it was in dev, right?
That's it, and the consistency, the fact that you're using a standard toolkit to deploy something anywhere on your route to live means that you have actually tested the deployment, because you completely agree that how a change was made in dev for unit test versus how the same change was deployed in production tended to be different, irrespective of whether it was KICS, DB2 or code.
Could have been different people as well, couldn't it? You might have had dev DBAs and prod DBAs. They all have different styles, but now it's a pipeline.
It's a pipeline, exactly, and you still have the same controls. So on the kind of autonomy alignment thing, you want the teams to be as flexible as possible, but organizations that run mainframes tend to be highly regulated. So there has to be an alignment with governance, and so your pipeline can become part of your governance. You can have governance as code. So you can have the correct gateways built into your pipeline. You can have the correct approvals. The approvals can be under version control as well. And
yeah, so you're still segregating duties, for audit purposes, but you can still produce, this latest graphic, a pile of cash, hashtag safely, reliably with pace, right?
That's it. So all these things independently give benefit, but when you combine them and you stack them up, you really strike gold.
Fantastic. And Ryan, thank you for your question. I will come to that question in a minute with Reg. So you've got a question from the audience, but we'll come to it in the Q&A section. So let's just get to your last three summary points, because 3 is a good number of things to remember. So number 1, consistency.
So this is back to build once, deploy anywhere. you want the developer experience to be consistent. So a standard toolkit, irrespective of the language the developer is developing in, a standard pipeline to deploy, irrespective of where the developer is going to ultimately deploy their application. You want to keep things consistent. You want them to be industry standard so that the new blood that arrives can start working and being productive from day one. Also, I think one last one is on the consistency and opinionated pipelines. So the pipelines can do some of the heavy lifting when it comes to compliance, for example.
Mm-hmm.
So ways of working, the unified experience, the one look and feel is really, really important, because what we want is developers who will be, I think we went from kind of guys who were deep in one technology or one application to we would like to see kind of T-shaped individuals who had a breadth of experience and one depth. We now want comb-shaped individuals. We want guys who know lots of things, who potentially know lots of applications or have been exposed to lots of applications, and who are comfortable working across different technology stacks. And this makes it interesting to come to work, okay? Because the engineers are generally curious, and they want to do a good job, and they want to solve a problem. And we want them to do that. We want to let them do it in as easy a way and as a productive way as possible.
And if you can move dev people around, then that brings a richness to their knowledge that, oh, hang on a minute, you know, I used to support this service, and that's not how they work. Or, oh, I know the person to go and talk to if we're going to have a dependency on an API or one of the services. So it's good, isn't it? You can break down the silos at a support level as well as on the human comb-shaped experience.
It's the move to true feature teams, to be honest. It's because you'll have engineers sitting next to each other working on a slice through the organization, and you'll have an engineer who's working on the Android or iOS mobile banking app, and he's in the same Scrum team as an engineer who's developing the service that supports that. Okay, and that could be a DB2 REST API, or it could be a COBOL Kix transaction. But they're sitting next to each other. They want to be able to talk the same language, so they'll be using Jira and they'll be using Confluence, and the thing they're working on will be different in syntax only. Somebody will be in JavaScript, somebody might be writing COBOL. So the alignment versus autonomy is back to getting the balance right. We are regulated organizations. There is governance we have to comply with, both internally from just good business practice and also externally with regulators. We want to go fast. The pipelines and the ability to build governance as code into those pipelines, so we can have an opinionated pipeline. So as well as the pipeline deciding which platform you're going to deploy your application to, the pipeline can ensure compliance. So if we have to scan something for vulnerabilities, and if we find a problem, we make sure the pipeline stops. Okay. I think since the likes of SolarWinds, and because we are taking more open source into the mainframe, we are potentially exposing it to some of the things that historically somebody would say was never a problem. So you have to if you're going to go down the modern mainframe tooling, you have to go all the way down the rabbit hole, and you have to do everything, and you have to ensure best practice and an opinionated pipeline incorporating the same technology that's proven in other stacks within your organization is the way to go. You don't have to reinvent it, because in the same way that a lot of technology from the mainframe has found its way into other technology stacks, we can start to feed off things that have been developed elsewhere, because the mainframe is just another platform in the data center.
Yeah, and by embedding checking of SQL for both that matches standards, and that it's going to be performant in production. All of those things bring autonomy, don't they? An engineer knows that it's going to do what it should do when it reaches those later stages of test and ultimately production. So it is it does bring benefits to people working. Actually, I'm going to bring that question up in a minute, but I think that the recent pandemic has highlighted how some of these the autonomy is a vital part of modern engineering. Okay, so we're getting into the Q&A, and I've got a couple of questions around this. I'll start with the first one. You've talked about modern processes and new tooling. How would you explain the people part of the equation around culture change?
So yeah, so the people, you have to bring the people on the journey, and certainly within Lloyds, as part of the engineering transformation, we have invested massively in the amount of training. The training has not been siloed. So engineers who primarily work on the mainframe have gone off and they have been on the same training courses as the engineers who would be working on Android apps. So they have learned how to use modern tools, how to use Git, what a branching strategy is, and what the different types of flow are for Git. There's been no silo between one platform and another. It's one large engineering community. And I think the engineers are also actively encouraged to experiment. So we've got time blocked out in our calendar. I've got Friday mornings, which is which has an hour in it blocked out for personal development, for me to go and kind of do my own personal experiments, learn something. And that's actively encouraged. We're an organisation with a real learning culture, and that has paid huge dividends in the engineering community.
Okay, and then a bit of a zoomed question on the culture. How did you overcome seasoned technicians not willing to use the modern IDE? This person that's asking the question has found that the new blood loved using an IDE, but senior techs preferred the green screen and their Rex procedures and tools, even after the senior techs used the modern IDE.
So that's one of the areas where we don't mandate. So we are multi-IDE. So we've got Topaz, VS Studio Code, IntelliJ, and we've got guys who still use the 3270. We don't prescribe one way over another. At the end of the day, the developers who are delivering in an agile DevOps enabled Scrum team have a commitment to deliver something within a sprint and to a certain quality. How they get there is the autonomy that's left to the developer. And to be honest, I've got on my machine, I've got Topaz, I've got VS Code, and I've got a 3270 emulator, and I use the tool that's most appropriate for the thing I'm trying to do. So if I am looking at a piece of code that I've never looked at before, I might go into Topaz and I'll use program analysis to find out how it all hangs together. If I am doing a relatively small quick change, VS Code, if I just want to run a Rex or edit a file or sub a job, I might just do 3270. So we don't, if a developer wants to use VS Code, we don't stop them using Eclipse, or we don't stop them using 3270. It's the tool that's most appropriate, and we do support them all.
So that's one solution there to the question, Ryan. I've also seen an organisation that, as they were transitioning from 3270 to a modern IDE, they started actually modifying the ISPF panels and disabling the ISPF features so that people were not driven, but diverted to using different tools, as they felt that was as an organisation, they felt that people would be more productive. So you can lead people or you can divert people. So that's it. And then there's another question. There is a difference between virtual IBMs and real IBMs. We hit friction for learning the nuances, and also the dev teams have to support the virtual environments because the teams that support the real LPARs didn't have the bandwidth to take on the virtual environments. How are your virtual environments supported?
Yeah, and actually we're the same. So the virtual environments are provided by my team. So we stamp out the golden images, and we are first port of call for people that have problems. But the question raiser is right. The dev team support the virtual environment. The dev team supports the ZDT. The dev team are responsible for getting their application in there. It's a voyage of discovery, but it doesn't expose your application developer to something that's normally done by the systems programmer. So it is a learning opportunity. I think within our organization, the disconnect, the historic disconnect between dev and operations staff, so the traditional systems programmers, is starting to blur. We are starting to get the teams working more closely together. So the systems programmers are, while they don't necessarily get their hands dirty on the virtual environments, will give pointers. And within our team, we do have access to some IBM Gold consultants who can get into the sticky mess. So we are kind of first line support for serious problems, but we do expect the dev teams to have a go first, because it is a voyage of discovery. It's a virtual machine. At the end of the day, if you break it, it's in a container, you stop it and start it again. We're also now starting to provide pipelines to solve common problems. So when we give these virtual environments over to the dev teams, we do stress the fact they're really ephemeral. They're there for a job. You're there, you spin one up, you do some testing in it. Once that piece of work's finished, you throw it away. You don't try and upgrade it, because we'll upgrade the master golden image and you just grab the current version off the shelf. So if you're not running on the current version, then you should be running on the current version. We will help you spin a new machine up. We'll give you a pipeline which will deal with common problems if you run these machines for ages. So the housekeeping that's done on the real tin doesn't get done on the ZDTs, so you could run out of space in the spool. You could run out of space in the underlying file system. So we'll give you a pipeline that will clear out the spool. We'll give you a pipeline that will add more storage under the covers. We'll give you a pipeline that will do an IPL on the box for you. So again, you can either learn the systems programming elements and do it yourself, or you can grab one of our, I think we were calling them Lego bricks at one point. We've now changed it to Jenga. So we now have probably 100+ little slices of Groovy script that you can run within Jenkins that will do an operation. So it'll either service something on your virtual box or spin you up a new one.
So you got Jenga blocks of expert solutions
Yes.
that can assist. And I'm guessing that some of the declarative pipelines just help you to spin up those environments so that the dev teams have got your assistance at first line, but ultimately with the repeatability of the pipelines, a lot of them are going to be spun up initially in the right format anyway. So as you were saying, just shut it down and start again and it comes up clean.
Yeah, so it's a partnership. So if a dev team wants to get on board with using a virtual environment, then my team will help. We kind of spent a lot of time, okay, when I was the customer, we spent a lot of time building automation that supported primarily online environments. We've got a team who came to us at the end of last year who were exclusively batch. So their application was a big ETL setup. Okay, and so we worked with them to build a pipeline which would suck their schedule out of production, analyze the schedule, go off and grab the jobs, fully expand their JCL, find out what the data sets in their jobs were, and then replicate that down to a virtual ZDT, and then allow them to run the schedule on the ZDT. So we'll partner with a team who wants to give it a go. and we're pretty open to most things. And the way that we kind of then take that piece of knowledge and we share it, so we've got a library of accelerators, as we call them, so things we've done for other teams, so pipelines that will go off and spin up a virtual machine in our private cloud, install a ZDT on it, we will give to another team, and then we'll help them with the next stage, which is build the pipeline that then installs your application on top of that bare metal ZDT, and now you've got a pipeline that stamps out your application.
Yeah.
And we'll share those that technology around the group. So while we worked with the team for 3 months to do the work to set up their batch application, we've now got a repeatable pattern we can give to any other team that runs a batch application that says, right, we can automate the whole creation process for you and give you a ZDT, and you can use that as a disposable test environment.
So I want to just loop back to the poll question, because all of this stuff would work with parallel development, but at Lloyds Banking Group, you're going with a very modern approach to your source code around trunk-based. Is it called trunk-based development? It is. Yeah, trunk-based development. So
yes.
Could you just share for those people who don't know what trunk-based development is?
So trunk-based development is, shall we say, it's an aspiration. So trunk-based development is where the developers effectively all work on one branch. So all your work is on a single branch. A developer will make a change, and then they'll check that change back after it's been unit tested back into that single branch. So the developer's individual branches are very short-lived, ideally only a day or two. And the idea is that the trunk can be deployed to production at any time. That does need things like feature switches. So if you've got I'm trying to think of a nice word, an application that has been around for a long time, that might be quite hard to do. It's easier to do with new build applications because you can build feature switches in from day one. So it's not for everybody. There are other patterns which are close. So there is Git hub flow as opposed to Git flow. So Git hub flow is a feature branch which lives for the time it takes to deliver a particular feature. That might be a product enhancement, so the branch might be around for several weeks before it goes into production. That doesn't need feature switches because it is a traditional merge from a feature branch into production. And it's easier to manage than Git flow, which is another branching strategy. So Git flow, if you have a traditional release management pattern and you want to go to parallel development using Git flow is probably the way to go, but it doesn't lend itself easily to kind of CI/CD practices because it is heavily geared around a kind of release management pattern. So trunk-based absolutely is the aspirational endpoint because that is short,
short-lived parallel development. It's just checked out, fixed, and checked back in.
Yes, short, sharp, release on demand.
Okay, and if you're going to test stuff, now the question that's come in, and I know this is right up your street because I've heard your answer to this. Are you using base test data in an environment that is refreshed on some frequency, daily, monthly, IPL, etc.? So automated test results, scans and compares are built into your DevOps pipeline.
Yes, that's the short answer. Okay, so yeah, so the test environments are empty. We manufacture test data. So our quality engineering team, they had quite a good idea a couple of years ago. So the bank have lots of APIs that are used by the front end systems to call back end systems to do things like create customers, create accounts, etc., move things through the life cycle, create cards. So rather than risk all the GDPR implications of trying to take data from production and tidy it up and depersonalize it, why not just have scripts that come along and create your application test data from scratch? So exercise the APIs like you are the front end system. And then you can snapshot that manufactured environment, and that becomes your baseline. So you then can apply on top of that your repeatable tests from a known baseline and check the outcome. And that works for both batch and for online. So tool sets are different, but you can build things like, you can use FileAid to create assertions to look for things in particular files, in particular fields. We have online tools which are part of the pipeline, which exercise the APIs as we deploy. So the application I worked on had somewhere in the region of 50 or 60 SOAP and REST APIs, and we had a regression test pack which fired each of those APIs when you deployed a change to an integration test environment to make sure that everything still worked effectively on the kind of smoking gun principle that last man in probably wrecked the system. But those tests are again something else that's versioned in Git. And one of our batch teams, they got to the point where they were using X-ray tests to trigger things. So you had a story in Jira to do something to a component. There was an X-ray test for that component. You tag the X-ray test onto the Jira story, and the test fires automatically.
Yeah, I think it's a great question. And if you don't mind me having an opinion on Lloyds, I think that you solved the test data problem very early on in your journey. And I think a lot of people don't do that. They think about the infrastructure, they think about the environments, and then they start finding that stuff doesn't always run as expected, or they've got too much data or trying to use too much data, and then they address the data. So that's why I thought it was a great question, Ryan, because you need good data, test data to successfully test things and get the right sort of code coverage and the sonar analytics, etc., that come out of code coverage. So I think that was a really positive thing that Lloyds Banking Group did with the synthetic data in your portal and stuff to give individuals good test data from a very early part of your journey. Right, I think we've got time for one more question. So you brought it up, Reg, about autonomy. What sort of benefits from this modernisation have you seen during the COVID pandemic?
I think there's been an explosion of creativity amongst the developers, to be honest. I think with they certainly rose to the challenge of kind of working remotely, which was possible. Running up to COVID, we were doing lots of work around co-location and bringing the teams together to kind of improve flow, getting everybody sitting around the one table as a proper feature team. Going into the pandemic, that was kind of a bit of the unknown, but I think the tooling, the collaboration tooling, so the use of Teams and the innovative use of Teams and the use of things like Teams webhook notifications, so the guys have built things into their test pipelines. So the same way you would put, if you're using Slack, you could post a message to Slack to say my test is run, my test has failed. Guys, we're a Teams organization, so we've started doing that so that we've got automation as part of the pipeline, which posts messages back into Teams channels. So I think that there has been an explosion of creativity. So guys thinking outside the box with what we can do with the tools we started with the pandemic, the tools that arrived during the pandemic, to kind of collaborate and do things better. There's been less working in silos. You think that it kind of, it's not the thing you would expect, I think the teams have made use of things like this. So to be able to actually have a real conversation with somebody, it still happens, even though, like, so I'm in Edinburgh, and the vast bulk of my team are in Norfolk, and we kind of get together in London. So we don't have to be around the same desk anymore, to be honest. We get around the same desk once a fortnight. But we've learned to interact this way. Yeah, it's a very woolly answer, Stuart, sorry.
No, I think the goodness is that, you know, you embraced it as a compelling event, and that innovation has been taken. You know, it's not been panic stations and lock things down. You've actually continued to innovate. I know that in VS Code there's like a sharing opportunity, isn't there, that you can still work together on a piece of source code through those sort of IDEs, or that particular IDE offers that capability. So you don't necessarily have to be sitting on top of each other around a keyboard. You can do that virtually. And it's a bit about using the modernization and the IDE.
Exactly.
But,
and it's bits of Teams, bits of Confluence, bits of Git, to be honest. But they all have collaboration elements, and I think the teams have embraced it.
Going back to the Accelerate state of DevOps, they're talking about including documentation as one of their measuring points, and I think that's another advantage of having Git as your version control, because your documentation, your test cases, your source code, your anything can all be co-located. So it's not, new people don't have to say, well, where do I go to look for this? What's that directory again? It's just in the repo.
Yes, absolutely.
Right, well, thank you, Reg. And it's been really good to understand the mainframe's just another server, and you're mimicking with the emulation through ZD&T of mainframe LPARs in containers. It's just what the cloud native development teams have been doing. So it just gives the same sort of approach and the same feel to organization, to engineers, doesn't it? They don't have to think that the mainframe is that black and white picture that you showed at the very beginning, that we aren't living in black and white when it's around mainframe development. It's all as modern, and the approaches and the tooling and the outcomes mean that the mainframe is just another server, but it's an equal part of the any organizational enterprise.
Yep, and version control everything.
Okay, so from the poll, we had 57% say that they were going to be looking at Git, and 17% said they are working towards that now. So I just want to promote a BMC ebook about Git for the mainframe. This isn't endorsed by Lloyds Banking Group. I just want to make that clear that this is a BMC ebook, but we recognise that Git is a reality for the next generation of version control. So we put together with some industry experts this ebook, and we can follow up with you to send you a copy, or you can reach out to your account team and they'd be happy to have a discussion about how Git and the mainframe and all of the beautiful automation opportunities that come with that can be exploited. And Reg is absolutely happy for you to reach out to him and connect on LinkedIn if you have any questions directly. Same for me. I'm happy to always have a chat about these things. It's always interesting to get questions or conundrums to think about. So please feel free to continue the discussion with Reg and myself beyond this webinar. So the recording will be available at sometime in the very near future. And Stacey, is there anything else I need to mention before we close?
Nope, we are all good.
Well, there you go. Thank you to all the attendees. Reg, it's always a pleasure talking to you and listening to your insights. And I'm excited to see you perhaps at the GSE event in November, where the next iteration, another 5 or 6 months worth of effort comes to light. So anybody that is mainframe related, there are always physical events for us to come and get together and have a beverage and discuss what's good and what's not so good in the mainframe world. So GSE, talk to your organisations and see if you can come along to that. It's based out of Northampton. BMC will be there. I will be there. I lead the application development track. So also, if you want to reach out and ask for any topics to be hosted there, that's all good stuff. Reg is a great contributor to that, and lots of others. Right, that's it. Stacey, can I end the webinar?
You certainly can.
Okay. Thanks all. Cheers, Reg. Bye.
Sure.